Here you will be learning about the initial value theorem and final value theorem in Laplace transform. Okay, so initial value theorem, this theorem is actually used to find the initial value of f of t using Laplace transform, and this theorem is used if you want to find the final value of f of t using Laplace transform. Okay, what is the meaning of initial value? Initial value means the starting value. See, here we all know that the f of 0, that is f of 0 is called as the initial value. That's the first value, because here you are using unilateral Laplace transform, right? Which means the integral is from 0 to infinity. The integral is from 0 to infinity f of t e raised to minus st dt. This is the equation for unilateral Laplace transform. So here the first value, the time, this starts from 0. So which means f of 0 is the initial value. That is why it's called as the initial value. So if you want to find the initial value, okay, all you need to do is apply this equation. That is, limit as t tends to 0, f of t is equal to, limit as t tends to 0, f of t is equal to, means f of 0 itself, okay, small letter f of 0. This is the called as the initial value. This is nothing but, now look over here, this is limit as s tends to infinity, s into f of s. That means if you want to find the initial value theorem using Laplace, what you need to do is find f of s, multiply that f of s with s, and then substitute the value of s as infinity. Okay, but before substituting the value of s as infinity, you need to make some slight modification to the signal. Otherwise, you will get the value as infinity or not defined. So what you need to do over here is, once when you multiply your f of s, once after finding f of s, you multiply that f of s with s, and after that, when you are substituting the value of s as infinity, make some small modification to the function so that you will get a finite value when you substitute that as s tends to infinity. Okay, that is the first step that you need to do. That is what this initial value theorem is all about. Okay, now look at the final value theorem. Final value theorem, here we know that the final value is infinity, so therefore f of infinity is what you represent as the final value of f of t. So in that case, it's here according to final value theorem, just like this over here also, it states that if the Laplace transform of f of t is f of s, then the limit as t tends to infinity. That is the final value theorem, f of infinity. Limit as t tends to infinity of f of t, or when f of infinity, this is also called as f of infinity, okay, is equal to limit as s tends to 0, s into f of s. Okay, if you compare these two equations, this is the only thing that is differences over here. That is, if you want to find the initial value theorem, substitute the limit as s tends to infinity. And over here, if you want to find the final value theorem, substitute the value of limit as s tends to 0. So here also the process is the same. That is, first you find the Laplace transform f of s, then you multiply that f of s with s, and then you substitute the every value of s in that equation with 0. Like that, you will get the final value. Okay, that's all. This is the process is very simple. Okay, so let's do some problem based on these two theorems. Okay, so the first theorem we will do is this one. That is, we'll do this problem. Verify the initial and the final value theorems of this function. That is, e raised to minus t into t plus 1 the whole square. Okay, that's the first question. Let's do this. So here the given is that f of t is equal to e raised to minus t into t plus 1 the whole square. Okay, this is the f of t. Now if you look at both the theorems, that is both the initial value theorem and the final value theorem, you can see that in both the theorems we require this function s into f of s, which means you need to find the Laplace transform and then you multiply that Laplace transform with s. That's the first thing. So that is what I'm going to do over here. Okay, that is, I'm going to find the value of f of s first. Okay, so to find the f of s over here, yeah, I need to expand this, otherwise I can't find the Laplace transform, right? That's the only way. So let me expand this. So in that case, I can say that f of t is equal to, let me see, this can be written as e raised to minus t into t square plus 2t plus 1. Okay, this is the full expansion. So now I can find the Laplace transform of this, right? Because this is also equal to e raised to minus t into t square plus 2 into e raised to minus t into t plus e raised to minus t. Okay, this is f of t. So therefore I can say that f of s, that is the Laplace transform of f of t, is nothing but the Laplace transform of e raised to minus t into t square, okay, plus 2 into the Laplace transform of e raised to minus t into t, okay, plus Laplace transform of e raised to minus t, okay. So now this is very simple, right? Now what is the Laplace transform of e raised to minus t square? The Laplace transform of t square is 2 factorial by s cube, right? Or 2 by s cube. 2 by s cube is the Laplace transform, and then I need to frequency shift it. Okay, I need to shift its frequency. Here, what is how much I should shift it? This is e raised to minus t, right? So e raised to minus at becomes 1 by s plus a. So this is e raised to value of a is 1. So therefore, it will be 2 by s cube, right? So 2 by s cube will now become 2 by s plus 1 the whole cube. That is that s is replaced by s plus 1 by frequency shifting property, right? Plus over here also, what is the Laplace transform of t? The Laplace transform of t is 1 by s square, and then replace that s with s plus 1. So this will become 2 by 2 into 1 by s. So 1 by s becomes s plus 1. So this will become s plus, or Laplace transform of t is 1 by s square. So this is nothing but 2 by s plus 1 the whole square, okay, plus what is the Laplace transform of e raised to minus t? That is nothing but 1 by s plus 1, okay. The Laplace transform of t is not 1 by s. The Laplace transform of t is 1 by s square. The Laplace transform of 1 is 1 by s. That's why it became s plus 1. The Laplace transform of t is 1 by s square. So that s square will become s plus 1 the whole square. That is that s becomes s plus 1, okay. So now I found this. Now I can simply find the value of s f of s, right? S f of s is nothing but simply multiply this entire equation with s. This will become 2s by s plus 1 the whole cube plus 2s by s plus 1 the whole square plus s by s plus 1, okay. Now I can apply my now I can verify my initial value theorem and final value theorem. So according to initial value theorem, that is limit as t tends to 0 f of t is equal to limit as s tends to infinity s into f of s, okay. This is the initial value theorem. So now I need to verify it, okay, which means if I substitute the value as limit as t tends to 0 f of t, and if I substitute the value of limit as s tends to infinity s into f of s, I should get the same value. If I don't get the same value, then there's something wrong with my answer. Oh my god. So here limit as t tends to 0 f of t, right? So what is the value of f of t? This is the value of f of t. So therefore limit as t tends to 0 f of t is e raised to minus t into t plus 1 the whole square, okay. This is equal to, so substituting t as 0, I will get e raised to 0 into 0 plus 1 the whole square, which is equal to 1, okay. So therefore the initial value in time domain is 1, so therefore the value in s domain should also be 1. Let me check. Limit as s tends to infinity s into f of s, okay, is equal to limit as s tends to infinity. What is the value of s into f of s? That we just found out, right? Just nothing but 2s by s plus 1 the whole cube plus 2s by s plus 1 the whole square plus s by s plus 1, okay. So the thing is, you cannot directly substitute the value of s as infinity over here in this case, because the reason is you will get infinity by infinity, which is not defined. That is why. So you cannot substitute the value of s directly as infinity. What you need to do for these kind of questions, what you need to do is just simply represent every s in its reciprocal form, okay. That's all you need to do. Simply replace every s in the denominator, okay. Make every s as a fraction, as 1 by s. Make every s, change every s into 1 by s or 1 by s square or 1 by s cube, okay, because 1 by infinity is 0, so you can utilize that property over here. So what I'm going to do is limit as s tends to infinity. What I'm going to do is, here you can see this is 2s by s plus 1 the whole cube, right? So which means I can divide both the numerator and my denominator with s cube. So what will I get if I divide both of them with s cube? If I divide the numerator by s cube, I will get 2 by s square divided by, and if I divide this equation by s cube, the denominator by s cube, I will get 1 plus 1 by s the whole cube. Okay, plus over here also I need to represent both of them in terms of reciprocal of s. So here it is s square over here, right? So s plus 1 the whole square means there's an s square inside this. So what I will do is I will divide both the numerator and the denominator by s square. So this will become 2 by s, right? And this will become 1 plus 1 by s the whole square. That is dividing both the numerator and the denominator by s square. Okay, plus, and what about over here? Here I can just need to divide both the numerator and my denominator with s. So if I divide this by s, this will become 1 by, and if I divide the denominator by s, this will become 1 plus 1 by s. Okay, so now I can substitute the value of s as infinity, because wherever you see this divide by s, all those will become 0. So therefore the value becomes, here this will become 0 by 1 plus 0 plus 0 by 1 plus 0 plus 1 by 1 plus 0. Okay, this is nothing, this whole thing is nothing but 1 itself, which means it is verified. Initial value theorem is verified. Okay, hence LHS is equal to RHS. Okay, now in the same way I can now use the final value theorem. Okay, so to find the final value theorem, all you need to do is, we know that limit as t tends to infinity f of t is equal to limit as s tends to 0 s into f of s. Okay, so what is limit as t tends to infinity f of t? Let me see over here. That is limit as t tends to infinity f of t. What is f of t? F of t is e raised to minus t into t plus 1 the whole square. Okay, so this will become e raised to minus infinity into infinity plus 1 the whole square. E raised to minus infinity is 0. Anything multiplied by 0 is 0 itself. So this is 0, which means the other equation should also be 0. That is limit as s tends to 0 s into f of s. Okay, this will become limit as s tends to 0 of, this is nothing but 2s by s into f of s is 2s by s plus 1 the whole cube plus 2s by s plus 1 the whole square plus s by s plus 1, which is equal to, if I substitute s over here, this will become 0 by 0 plus 1 the whole cube plus, this is nothing but 0 by 0 plus 1, this is also nothing but 0 by 0 plus 1. Okay, which is nothing but 0 itself. So which means both the values, so here also the final value theorem is verified. This is how we check, this is how we verify the initial value and final value theorem. Okay, so in this all these problems, what you do is, first you find f of t, first you take f of t, then you find the value of f of s, then you multiply that f of s with s, then you apply both the initial value equation and the final value equation. Okay, let's do another question. Let's do this question. That is, verify the initial value and final value theorem of this equation, that is e raised to minus t into t square plus cos 3t. Okay, let's do this question. So here the f of t, the value of f of t is equal to e raised to minus t into t square plus cos 3t. Okay, this is the value of f of t. So what I can, this is nothing, this is also equal to writing e raised to minus t into t square plus e raised to minus t into cos 3t, correct? This can also be written like that. So therefore the Laplace transfer is f of s is nothing but the Laplace transform of e raised to minus t square plus the Laplace transform of e raised to minus t cos 3t. Okay, So what is the Laplace transform of e raised to minus t square? The Laplace transform of this is 2 by s cube, right? 2 factorial by s cube or 2 by s cube. So this will become 2 by s plus 1 the whole cube plus what about this? The Laplace transform of cos 3t. The Laplace transform of cos 3t is omega by s square plus omega square, right? No, not omega, it's s by s square plus omega square. So this will become s by s square plus 9, right? S by s square plus 9. So s by s square plus 9 will become s plus 1 by s plus 1 the whole square plus 9. Right? This is how the equation will be represented, right? So in that case, what is sf of s? Sf of s is nothing but 2s by s plus 1 the whole cube plus, and this is s into s plus 1 by s plus 1 the whole square plus 9. Okay, this is how the equation is. So now I am going to apply my initial value equation. So according to initial value theorem, limit as t tends to 0, f of t is equal to limit as s tends to infinity, s into f of s. Okay, now let me see if I get the answer. I should get the same answer. The limit as t tends to 0, f of t is equal to limit as t tends to 0. What is the value of f of t? This is the value of f of t, that is e raised to minus t into t square plus cos 3t, which is equal to e raised to 0 into 0 plus cos 3t. This is cos 0. Cos 0 is 1, e raised to 0 is 1, so you will get 1. Let me check now. Limit as s tends to infinity, s into f of s. Okay, that also I should get 1. Let me see. So here we know what is sf of s, right? As limit as s tends to infinity, s of f s is this one, that is 2s by s plus 1 the whole cube plus s square plus s by s plus 1 the whole square plus 9. Okay, this can also be written as, I can substitute the value of s as infinity. I'll get infinity by infinity, which is not defined. So what I'll do is I need to find the reciprocal of this. So reciprocal means over here, to find the reciprocal, here s plus 1 the whole cube. So the degree of it, the denominator is 3. So I think I'll divide this, both the numerator and denominator, by s cube. So I will get limit as s tends to infinity, and this will become 2s by s cube is 2 by s square by, and s plus 1 the whole cube by s cube is nothing but 1 plus 1 by s the whole cube plus, and over here also, here the highest degree is 2, right? So I will divide both the numerator and denominator by s square. So this will become 1 plus 1 by s, right? S by s square is 1 by s, and here this will become 1 plus 1 by s the whole square plus 9 by s square. Okay, this is dividing the denominator by s square. I will get this. Okay, so this is equal to, let me see, this is now if I substitute s as infinity, this will become 0 by 1 plus 0 the whole cube plus, and this is nothing but 1 plus 0 by 1 plus 0 the whole square plus 0. 9 by infinity is 0. So this will become 0, and this is 1 by 1, which is 1. So therefore both the answers correct. See, so hence the initial value theorem is verified. Okay, you can write that. Hence initial value theorem is verified. Okay, now next I'm going to verify my final value theorem. Okay, so to find the final value theorem, first I'll try to find the value of this at t tends to infinity. So limit as t tends to infinity, f of t is nothing but limit as t tends to infinity. What is the value of f of t? It is e raised to minus t into t square plus cos 3t. Okay, and as if you substitute t is to infinity, this becomes e raised to minus infinity, right? So e raised to minus infinity is 0. So anything multiplied with 0 is 0 itself. So this is 0. Okay, now let me find the value of limit as s tends to 0, sf of s. That also I should get 0. Let me see. Limit as s tends to 0, and what is s into f of s? It is 2s by s plus 1 the whole cube plus s square plus s by s plus 1 the whole square plus 9. Okay, so this is equal to 0 by 0 plus 1 the whole cube plus 0 plus 0 by 1 square plus 9, and this is nothing but 0 itself. Hence final value theorem is verified. Okay, it is always important that you mention the equation also. Okay, here I don't have the space to mention, that's why I didn't mention it. It's always good that you represent the equation of both the equations. I haven't written the initial final value theory equation, I need to represent that also. Okay, there is mark for that also. It's very important to mention the equation also. Whenever they are asked the initial value theorem or final value theorem, always you should write the equation. The equation also carries marks. Okay, let's do another question. Here the question is, find the initial and final values of the function whose Laplace transform is given by this two question. Okay, let's do this question. So first I'll find the initial value of this first question. Okay, so first question, here f of s is already given, so all I need to do is simply apply the equation. Plus 6s square plus 11s plus 6. Okay, so the first question is to find the initial value of this. So initial value means f of t at t tends to 0, or at t becomes 0, or f of 0. So f of 0 is equal to limit as s tends to infinity s into f of s. Okay, or this is also equal to limit as s tends to infinity. What is s is over here, and this will become 2s plus 1 by, this is s cube plus 6s square plus 11s plus 6. So what is the degree of the numerator? It is s square, right? Because this is 2s square plus s. So the degree of the numerator is s square, and then over here the degree is s cube. So in that case I will divide both my numerator and denominator with s cube. So therefore this will become 2s square by s cube is 2 by s. So this will become 2 by s plus, and this will become s by s cube is 1 by s square by, and over here you have, if I substitute the value, it will become 1 plus 6 by s plus 11 by s square plus 6 by s cube, or this is nothing but 0 plus 0 by 1 plus 0 plus 0 plus 0, which is 0. Therefore the initial value of this function is 0. Now let's find the final value. Final value is f of infinity, right? Or limit as t tends to infinity f of t. So this equation is nothing but limit as s tends to 0 s into f of s is equal to limit as s tends to 0 s into, and what is f of s? F of s is 2s plus 1 by s cube plus 6s plus 11s plus 6, and you will get over here as 0 plus 1 by 0 plus you will get 0 plus 1 by 0 plus 0 plus 0 plus 6, which means you will get 1 by 6. So the answer is 1 by 6. That is, the final value theorem is 1 by 6. The final value of this is 1 by 6. Okay, here also again I forgot to mention the equation. You should always mention the equation. Okay, limit as t tends to 0 f of t is equal to limit as s tends to infinity s in f of s. Okay, you should always mention the equation. Now I'm going to find the, and also limit as t tends to infinity f of t is equal to limit as s tends to 0 s of s. Okay, always you should mention the equation. Don't ever forget to mention the equation. Okay, I'll mention the equation for the second question. So second question is f of s is equal to s plus 6 by s into s plus 3. Okay, so in this case, according to initial value theorem, which is f of 0 is nothing but limit as t tends to 0, f of t, which is equal to limit as s tends to infinity, s into f of s, which is equal to limit as s tends to infinity, s into, and your f of s is s plus 6 by s into s plus 3. S and s will cancel, that's very good. So therefore makes both the so I just simply both the degrees 1, right? Here it is s, here is also s, so I think I will divide both of them by s. So this will become limit as s tends to infinity, limit as s tends to infinity, and this will become 1 plus, this will become 1 plus 6 by s by 1 plus 3 by s. Okay, 1 plus 6 by s plus 1 plus 3 by s, which is equal to 1. So there we found the initial value theorem. Now I found the initial value, now I'm going to find the final value. So final value theorem is, the equation is that is f of infinity is nothing but limit as t tends to infinity, f of t, which is nothing but limit as s tends to 0, s into f of s, okay, which is nothing but limit as s tends to 0, s into, and what is f of s? It is s plus 6 by s into s plus 3. S and s will get cancelled, so you will get s plus 6 by s plus 3, which is equal to, so here it is nothing but, here you will get 0 plus 6 by 0 plus 3, which is equal to 2. Therefore the final value of this is 2. Okay, this is how we do the problems. Okay.